Hello friends. Now let's have a look at some of the file systems, which are essentially data structures which are used to hold files. There are many file systems supported on Linux and they vary by virtue of functionalities. For example, one file system could provide faster access to files for time-critical applications or for faster file access. And other one could support larger file sizes, or it may be able to provide accounting services and automatic backup. Now let's have a look at some of the file system data supported by Linux. You might have heard of them or maybe observed them, or you have seen some of them, but some are not so common. The very first that we are gonna have quickly take a look at is extended 2 or second extended file system, which is natively for Linux, and it remained the dominant file system for most of the Linux distributions up till late 1990s. Extended 2 file system has been a very reliable file system, and it can support partition up till sizes of 32 TB. Though this extended 2 file system, it is reliable, but it lacked the facility of saving data against improper system shutdown or power outages. And in those cases, what happened is that once data was in the memory and was not written to the disk, then systems or the operating system used to run scanning for the disk, which is like file system check utility, where it sees that whether the files in the system or the disk is in the consistent state or not. So basically it lacked the functionality against interruptions and improper shutdowns, and that functionality was catered for in extended 3 file system, which has the support against improper shutdowns or uncalled for power interruptions by the facility which we call as journaling. So journaling, and there is a process which is journal daemon, which takes care of this journaling method. And what it really does is that once the files are put into memory, entry is made into the process of journals, where it knows that what files have been written to the disk and what have not been written to the disk. So in case some files have not been written to the disk and power goes out here and your machine gets shut down, then once the machine gets up again, this journaling, it looks into the logs and sees that what files have not been successfully written since the last boot. So once it finds those entries, it will put those contents which were in the memory and make the file system consistent. This extension 3, it can also support partition types up till 32 TB long. Both of these file systems can support files of up till 2 TB in size. So to cater for some of these limitations regarding this disk partition volume space or partition space and these file sizes, the next in the series of these extended file systems is extended 4, which does support up till 1 exabyte or 1 XB byte, and it supports a file size of up till 16 TB. So really a far better from these 2 systems. And other file system that is supported by Linux is Riser file system, written as REISER, named after an American computer programmer, Hans Riser. And this file system, it was built scratch with support of journaling for Linux, and it's particularly good for handling large number of files of small volumes, maybe up till 32 kilobytes. So large files less than 32 kilobyte, they are handled pretty good with this Riser file system. Then another one is JFS, which is journaled file system. It was developed by IBM systems for its AIX OS based operating system and also for OS2 based operating systems. So if you are familiar with IBM's these operating systems, you might want to use an advanced file system like GFS for your needs. Then we have another file system which is called as Extends File System, or read by XFS, which was designed by Graphics Intent or Silicon Graphics, which used this file system for their operating system, which was called as, so Silicon Graphics SGI developed this file system and was used in their operating system, which was called as RX OS, and they later donated this code for Linux. But some of the functionalities that were, this is very technically advanced file system, but some of the functionalities when it was donated to Linux, they really do not perform that well. So if you want to use file system XFS for your partitions, then you can use the code as XFS. Another file system which is closely related to XFS is BTRFS, which is also very efficient as of its robustness and speed, and is very much able to handle very large files and disks. Now let me just clear this slide and add a few more in here. Then we have this very common and very popular FAT or file allocation table file system, which is supported both by the DOS and Windows, and it makes it very popular in a sense because if we have got file system of FAT put on removable disks, then we are sure that if we put it into any operating system which is maybe operating DOS or maybe Windows or even Linux, then we will be able to access the files. Then we have got small variants of that like FAT16 or FAT32. Then we have new technology file system or NTFS, which is the preferred file system for Windows versions of NT and 2000, XP and Vista and so on and so forth. But unfortunately, Linux has rudimentary support for as far as reading, or reading is good. Reading is good as far as NTFS file system is concerned on Linux, but for writing files, it's not that great. But I have used this NTFS file system for some of my systems on Linux, and so far I have not faced any such problem as of writing files on the disk. Then there is another file system type which is specifically for Mac operating systems. So M is for, or I should remove this one, and so Mac operating systems, and this is called as hierarchical file system or hierarchical file system plus. So this is also supported by Linux. Now that we have seen some of the supported file system types by Linux, now let's see how we can actually create a file system type on a partition. And the commands that we can use are make file system, and then we can use a switch like maybe -T for type and then give it a file system type like NTFS maybe, or VFAT for FAT, or we can even use this MKFS. This make file system is just a front end, and it's front end of a command which is like mkfs.fat, or maybe if we are to make an extended to file system, then ext2. So now let's get on to the terminal and let's see how we can create a file system. So here I am at my Ubuntu terminal, and I have inserted a small SSD drive which is of 8 GB capacity in my USB, and now let's type in first the command which was, we know that how we can create the partitions. We have seen that using fdisk and jdisk, and also gparted. We have seen that the graphical interface for part editor, we can use the command line by typing in sudo partition editor and then the device itself. Make sure that the device is not mounted and it's formatted by using the partition editors that I had just mentioned. So I type in dev and the device is SDB. So I am put into that prompt, and over here you can see the commands by typing in help. So I want to see the current devices and available partitions if there are any. I type in print, and it shows me that the partition table on this SSD is MS-DOS and its capacity is around 8 GB. And also the file system at the moment is extended to. So now let's try to change this file system to maybe VFAT. Let's just get out of here and use the root privileges to do that and type in make file system. We can do that mkfs and -t, or maybe we can use mkfs.vfat, and after that we type in dev/sdb1 and press enter, and it will just take a while it creates the file system on this partition. And once it has created that, we can see the partition type or the file system type by typing in again either parted command that I just shown you, or we can also do sudo. Again we need to use the root privileges and then fdisk and then -l to list the partitions if there are any and their types on SDB drive. Alright, so this has only shown us the partition table type and not itself the file system type. We can use the parted command again on SDB drive, and I type in, let's say, print, and we see that the file system type has now been changed to FAT32. Likewise, we can use the mkfs.extended3 command to make extended3 file system type, or maybe extended4 for creating extended4 file system type. Or we can even use command like make file system -t and then MS-DOS to make an MS-DOS type of file system on that particular partition. Now you know that once we create the file systems on a drive, it is also recommended to create a swap partition so that it complements the RAM if RAM is full, so it can really faster the processing as far as file input and output operations with respect to the disk are concerned. So in order to create swap, since it's not a file system, it is a different type of storage, you can say. So the command to do that, to create a swap partition on or swap space on a partition, you can use the command sudo make swap and then the path. Since I have not created any partitions, any more partitions on this drive, which is SSD, so let's try to create a swap partition of all of these 8 GB. What you would do in practical scenarios is that if you have got let's say multiple gigabyte disk or maybe terabyte disk, then you will do the partitions as we have just learned in previous lectures, and afterwards you will mount them or create the file systems and then mount them, and also based on the amount of RAM available, you can create either the same size of swap or double the size of the RAM. Recommended is double the RAM of the size for your swap partition. So let's type in make swap on SDB1 and press enter, and it has created it. Let's just try to see if it has created successfully or not by going into partition editor command again, and then I type in print to see the contents of this, and we see that indeed the file system type is swap. Now once the swap partition is created, it needs to be activated. It is created, but it wouldn't work unless and until it gets activated, and the command to get it activated is sudo swap on and then the path which is SDB1. Now it is activated and we can use this space, this storage space, for swap purposes. Again, if you want to change this partition type to, let's say, extended file system second, we can do that by typing in make file system and then type is extended to and then the partition which was SDB1, and it has given us the error that since this was mounted, it was mounted in a way that we have made the swap partition active. So since it is active, it is not letting us create the file system on it. So we can turn off the swap on this partition by typing in swap off and afterwards try to create the file system again of type extended to, and this time it has successfully created and it is in the process of creating. It is creating this inode table. So let's just give it a while so that it successfully creates the extended to file system. It is also giving some information over here, for example the number of inodes and the number of blocks which are totally which will be in there. So it will take a while, and once it gets done, our extended to file system will be created, which it has. So it really depends how much is the size of the disk and what file system you are creating, and also the processing capacity or the machine that you are using to create the partitions in that particular storage device. So that's all there is to it. It's pretty simple stuff as far as file system creation is concerned. I hope now you know what are some of the file systems that are supported by Linux and how we can create them on our Linux machines. I hope you have learned from this video, and I would like to thank you for viewing.